We just launched version 3.1 on August 1st. We're very excited to show you the new VS Code interface, since that's the IDE most younger developers are trending toward.
XDC debugs not only in test, but we allow you to look into production and to be able to debug in production using authorized permissions.
So right now on my screen is the traditional VS Code editor. So I'm editing a high-level assembler file. So the typical workflow here is, you're using VS Code to edit your code. You make changes to your source, and then you use whatever method to assemble and compile and link edit that application. So if you're using Zoe, you can submit batch jobs through Zoe. We have a slightly different workflow. We still need a 3270 terminal on the side to do our builds. So once the build process has been done and you have an executable, so I'm going to actually be using Zoe for this demonstration. I can load up my batch file, my batch job, and I can edit this JCL and then submit it to kick off an XDC debugging session. So I'm going to do submit job here, and it'll say yes. And then I can open the job to see how the job is running. And what I'm looking for is this set of messages, this DBC 640Q message, that indicates that XDC has started and a debugging session is waiting for me to connect to. So now, once that's ready, I can go to our extension, which is this little icon here, and expand that and connect to a server that's running on ZLS that kind of sits in between VS Code and XDC. You'll basically list all the jobs that's pending for me, that's available for me to connect to. What you see here may be different depending on SAF rules, but this is my job, so I always see my job. And I can select it, right click, and then say connect to XDC GUI, and it'll actually churn a little bit, run some things, communicate with the GUI server, and then it basically then pop up a display of whatever you're debugging. And this is based off of, so you see the storage address, and then in this, I have 8 data source maps set up and loaded. So instead of seeing just a raw disassembly of storage, I actually get my source lines, including commentary, for the CSEC. So I can scroll up and down, however, wherever I want, and start setting breakpoints into places where I know execution will reach, and then basically start tracing through. So for example, I can set a breakpoint here just by clicking on this left gutter and then click go, and it'll just basically run. And then when execution hits that instruction, the XDC gains control, and we get control again in the VS Code. One other thing that we can do here is this loaded scripts. Let me minimize some of these. This loaded scripts panel. What this shows is all of the CSECs in the module that I'm actually debugging. And from there, I can click any one of those. It'll come up with churn. So right now, this is just a simple disassembly. Oh, actually, this is sim data, which is a different form of mapping information that just contains bind time information. So you get symbols and entry points and the lengths of your CSEC, and that's it. No source images, no commentary, nothing like that. But I can right click on it and select map to CSEC, which will pop up this helper dialog, which kind of you can change these things around as you need to. I'm going to set it as auto detect, so whichever mapping information is available, sim or A data, or no mapping information, and I can click execute, and then it'll do its thing, and it'll run, and then I can close it, and then the previous display will refresh, and now, oh, it's actually this guy, and now my source map has been loaded. So the goal with our extension really is to try to keep all of your development here in VS Code so that you don't have to context switch between VS Code and 3270. Everything is kind of done right here. So your workflow, your flow state doesn't get interrupted because you have to swap tools and the swap mentality to how to use 3270 versus VS Code. So this is the sort of thing that we're working on and improving. And now that I have this DVC disk IO CSEC open, I can then again just go and start setting breakpoints, and then issue go, or however I'm going to trigger this section of code. It will trigger and hit the breakpoint, and then I can control again. A couple other things that we're that we want to improve the developer experience by providing an easy and visual way of accessing information about the system. So one of the things that we have in the base XDC product is a command called list subpools. And what that shows is the amount of storage usage in the current address space. So this will show you your 24-bit usage, how much is in use, how much is free, 31-bit, and it'll give you a total information as well. There are operands, this list subpools that we have not yet implemented in list subpools in VS Code, and that's basically, and all that information really is subpool information. So we'll break down 31-bit by subpool usage, and it'll show you what the blocks are, how much is in use, how much is allocated in that subpool. That's where we're coming along. So at some point we'll be enhancing this display. Other things that we have, especially if you work in assembler and you're doing low-level code, you may care about the contents of the control registers. Now, the control registers basically has 5 bits that indicates certain capabilities, certain functionality that exists or doesn't exist for your address space. So what we're working on is basically breaking down the control registers into a easy and simple way of just looking, seeing, okay, trace TLD clock, it's set. Okay, that flag's on, clear, that's not set. So right now we have control. We're going to work through the list and get all 16 registers formatted out this way. Related to this, the register display in the variables panel will also have similar information as well. So you can use either one. It just depends on what your preference is and how fast you want to get to it. Another thing that we have in VS Code, which hopefully help developers, is a way to quickly and easily look at storage. Right now, it's just a raw dump of storage, and we're enhancing this functionality to tie into our ability to load AData maps for your CSEX. So once you have an AData map loaded, you can tell XDC to place this map onto a chunk of storage. And then when we go view that storage, it's formatted out like this with your source code and commentary. So that's actually currently in the works right now. We don't have anything to show for that, but we're being worked on. So with this AData EBCDIC panel display, we have a variety of options. You can choose different EBCDIC code pages, as well as if you're working in ASCII, we will happily convert the text portion into ASCII for you, so you don't have to do the mental gymnastics to do so. We allow you to search for patterns either via the raw hex or by the text. And then you can also just page through storage. Another sort of, helpful quick access, if you have if I open the control register, the general purpose registers, and I expand R13, there's a little hover up that pops up over here. And now basically, if you click it, it will basically take the address in the lower half of R13 and then pop it up in the display panel so that you can actually go ahead and look at what that storage looks like. Just, little things to help improve developer efficiency. So you don't have to manually issue a command to say, hey, I want to see what R13 points to. You can just, hover over, click a button, and here it is. Now, what we've done is if you open up the debug console, it's standard as part of VS Code, you can actually issue all XDC commands. So when I'm going to load, there's a dmap command. I am going to load the AData map for the TCP control block. So this tell you that it's loaded, and then I am going to then place that DSEC map onto TCP number 5. So now, so because, like I said, this functionality that I'm about to show right here, my TCP number 5, where it actually shows you the DSEC map overlaid on top of the TCP control block, that's functionality we're working on right now so that it's more integrated into VS Code. What I want to do here, however, is this. So I can take this field, TCP. One of the things that we've done is if you go to the watch window, so the watch window in VS Code is a place where you can manually add variables to keep an eye on, and it will update as you're tracing through your code. We don't have the ability to just right click and add right now. There's some trickiness in getting that to work correctly. So that's something we're thinking about and working on. But what you can do, however, add a XDC command. So the XDC has a show command, and now it's tagged in that watch window. So as you're stepping through your code, this field will now always be updated. Now, the VS Code extension only implements a small subset of XDC commands. So XDC's been around for 40 some odd years, and there's over 200 some odd commands. We've only kind of migrated over about a dozen for this initial launch. As we go forward, we'll be implementing more and more commands and adding more and more functionality that the base XDC product has, and move it into VS Code so that the transition between the two, there's some parity between the two, with VS Code versus 3270.